One of the technical challenges in dealing with logarithms, especially with the calculators we're using in this class, is that we only actually have buttons for logarithm base 10 or base e. And we might be asked to do powers of 2, for example. A lot of computer science examples would use log base 2, and occasionally other bases come up. Exponentials, on the other hand, we can always do. There's a power button on your calculator, so there's no challenge changing with different bases for exponents, but for logarithms there is one. So fortunately, it's a fairly simple short side calculation required to calculate the log of some new base of a value compared to log base e or base 10, which are available in your calculator. So let's just take a look at the statement we're going to use here. If we need to find the log base a of some number, it turns out we can take the log of that same number, base 10, and then just normalize it by the log base 10 of the base we were supposed to use in the first place. And this, of course, is all calculations we can do with the calculator. This may not be one that we can do with the calculator. Let's just quickly prove that, just using the relationship between logs and exponentials. So let's let the value we want be equal to c. Okay? So c is the value we want. We want to find that value, but we can't find it immediately, but at least we can recast this as x is equal to a to the c, courtesy of our relationship between the log and the exponent versions. What we can do next is, let's take log base 10 of both sides of this new equation. What will that give us? It'll give us log base 10 of x is equal to log base 10 of a to the c. Well, we can still, even though we don't have a log base a like we started with, we do have a log of some exponent, so we can actually use our third rule for logs to bring the c down front. So that can be c log base 10 of a. But remember, c is actually the value we are looking for. So if we solve for c, we're going to get exactly what we need. So c would be log base 10 of x divided by log base 10 of a. We bring this part here down to the other side. Well, what did c start off with? It was log base a of x. So that's our proof that the value we want, log base some strange number, can be computed as log base 10 of x over log base 10 of a. Let's now consider a simple example and just one of the issues of scale that comes up sometimes when we're doing calculations. Imagine trying to calculate log base 10 of 1,000 and log base 2 of 1,000 and just ask which of those would be larger. Let's do it first without calculation, and then we'll use the change of base formula we just saw. Remember, the equivalency here is 10 to the something is equal to 1,000. That would be the exponential equivalent statement. And of course, this number up here has to be 3. So log base 10 of 1,000 is simply 3. But how does that compare to log base 2 of 1,000? Well, the equivalent statement would be 2 to the something is equal to 1,000. And you think 10 goes 10, 100, 1,000. 2 goes 2, 4, 8, 16, 32. It's going to take a lot higher power to get to 1,000 than 10 to the something. So in other words, we're going to need a higher power for 2 here, and what that means is the log base 2 of 1,000 is going to be larger than log base 10 of 1,000. It'll take a larger power of 2 to get to 1,000 than it will take a power of 10. Now, just to confirm that that's actually the case, let's quickly take the log 10 of 1,000. Well, we can do that one just by inspection. That's simply 3, while log base 2 of 1,000 is a little trickier. That's not in our calculator, but we can use that change of base formula. And we might as well make it base 10 as well. So we can say that's the same as log base 10 of 1,000 So we just change the base to 10, but then we divide by log base 10 of 2. And what we'll see here is there's not much of a power of 10 to get to 2. In fact, it's less than 1. So let's actually do this in pieces. If we take our calculator out, we find a value here of approximately 0.301, and dividing those, we're going to get a value around 9. So clearly log base 2 of 1,000 is much higher. It's around 9 compared to log base 10 of 1,000. So that just helps us with some ballpark calculations. For future reference, since base 10 is so commonly used, sometimes when we do the log expression log base 10, that gets a bit tedious. So we would just do it without the base. So anytime in our notes, if you see log without a base, it means base 10. How do we express the other commonly used logarithm base, base e? We use ln, or the natural logarithm. That's what the ln is for, natural logarithm, instead of specifying log base e. So it's just short form ln and log base e base 10.